Today I'm going to speak about technical debt and address some of the myths and realities on that concept. I'm Philippe Kruchten. I used to be a professor of software engineering at the University of British Columbia. And before that, I worked with Rational Software, now IBM. What is technical debt? Where does it fit in the general software engineering landscape? What are the limits of this metaphor? And what kind of practical steps can we take about it? Is what I will be speaking about. If you have just 1 minute, these are the key takeaways. All software systems, especially when they're large and long-lived, they accumulate technical debt. And technical debt is different than defects. How much technical debt you actually suffer from depends on the future evolution of the system and not just its past. While code-level debt is easy to identify today and to remediate, architectural debt has a high cost of ownership. And being agile does not make you immune to technical debt. So this metaphor was introduced a long time by Ward Cunningham. Until 2010, it was very often mentioned in the general blogosphere, but rarely studied. All experienced software developers feel it, and it drags long-lived project and product down. So the metaphor started in a little paper presented by Ward Cunningham at a conference here in Vancouver a long, long time ago. And he described the thing that you do, the not quite right code that you had to do to achieve a certain release as a debt. Only much later, Steve McConnell hooked on the idea of technical debt and started to look at it and found that there are different types of technical debt. There's a lot of technical debt that is unintentional, non-strategic. They're just poor coding, poor design decision. We used to call them code smells now. And then there is intentional and strategic technical debt that you take deliberately, knowing what you're doing, to achieve something, usually to achieve, to relieve time pressure. And then two things happen. Short-term debt, that is you paid off quickly the debt and things are back to normal, or you sit on it and it becomes long-term debt and you start suffering from it. So Steve is the first one who gave a definition to technical debt. And that definition, we've expanded it a little bit a few years ago. So today, technical debt, well, in software-intensive system, we're not claiming that it addresses other type of system. Technical debt is the collection of design or implementation constructs that are expedient in the short term, but set up a technical context that makes future changes more costly or impossible. So technical debt is mostly about maintainability and evolvability of the system, how easy it will be to evolve the system later on. So where does technical debt fit in the concept of software engineering? Technical debt is what is in that box there, and there's different forms and we'll come into that. Technical debt is mostly invisible. Users of your product do not see the technical debt. Only software developers see the technical debt. On the left-hand side, you have new features, additional functionality. This is visible. If you're missing a functionality, if you have ideas on how the product should evolve, that's visible. On the right-hand side, you have defects and low external quality. So technical debt, you can look at it from this perspective. There is visible stuff that you have in your backlog, and invisible stuff. And there's stuff that add positive value and stuff that add negative value. So new features, added functionality, this is the green stuff. This is visible and it has positive value. A little bit harder is architectural stuff. You know, it's not visible to the end user, but you know that it brings positive value to your product. Then the red stuff, it's obvious. Visible and negative value, that are the defects. Technical debt, well, fills that fourth quadrant. It's both invisible and it has negative value. So on the right-hand side here, we have technical debt that is basically low internal quality. Code smells, code complexity, coding style violations. This is something that's going to affect maintainability of your system. So it's McConnell type 1 and 2A. Lots of tools exist nowadays, static analyzers that will point you to potential technical debt. And there's also the self-admitted technical debt. You know, when you wrote a piece of code and you say, oh, I'll fix this later, or I'll come back here later, or this is not quite right. Or so what causes technical debt at that level? It's mostly schedule pressure and more schedule pressure. Sometimes ignorance of a better way. Sometimes it's just success. You've been very successful with a release, and there is a tremendous push to add new features to your system. Sometimes it's your environment that evolves, both the technical environment and the business environment. So something that looked like the right decision at the time you took it, now, you know, 2 or 3 years later, well, it looks like technical debt. And in some cases, it's just a little bit of sloppiness on the part of the software developers, but that's not the main cause. So what can you do about it? Well, constant debt reduction. The fact that we have now most organizations use an iterative development process makes it a little bit easier to identify, reduce technical debt at a regular interval. On the left-hand side of my technical debt box, you have architectural debt. That's a little bit more difficult. It takes different forms. You had a startup company, you had this minimal viable product, and guess what? The choices that you've made to build that MVP stuck forever. Or you have some difficulties finding some way forward, and you have a workaround around a defect or to build a new feature, and that workaround stayed. Or you're reinventing the wheel. You're building a lot of code that actually could have been acquired externally, where it's maintained open source code, for example, and you are now stuck maintaining your own code for the system that you've built. Poor separation of concerns, architectural locked in, new context, old architecture. I've already described this. Architectural debt, the main cause is the same, time pressure. But in many cases, it's also lack of architectural knowledge. For large, long-lived systems, it's lack of architectural documentation. Some of the ideas of the original designers of the system have been forgotten, and there is some architectural degradation in some ways. And then there's human factors. We come to software development with our own biases, the thing we know, the thing we ignore, and there's the passing of time. But as Steve McConnell noted, if we have no interest, maybe it's not a debt. So what are the interests that we're speaking about here? Well, in presence of technical debt, whether it's at the code level or the architectural level, the cost of adding new features is higher, which means that your team velocity is lower. Actually, that's usually one of the first symptoms in organizations that start suffering from technical debt. When repaying technical debt, that is when you fix the code or you remediate it or you do now the right thing after having done the wrong thing, there is some additional cost for retrofitting already implemented features if you have dependent code on the top of the code that you have to remediate. So technical debt that is not repaid lead to increased cost forever. So there's a few myths about technical debt. Walt Cunningham invented it in '92, or it's just a new fancy name for defects, or we can just buy a tool and that will tell us all the technical debt that we have, or we can measure technical debt and put a dollar value on it. Technical debt is very bad and should be avoided at all. And agile teams are immune to technical debt. Okay, the first thing to remember, technical debt is just a metaphor. And we have to see where the metaphor breaks. A metaphor basically takes idea from one domain and project it in another domain. So technical debt depends on the future, not the past. If you have a mortgage on your house, well, that's something that was decided in the past with a bank, and whatever you're going to do in the future does not change your mortgage. Well, technical debt will depend on the future, and we'll see that. Technical debt cannot be measured. You can walk away from technical debt. We can just leave it there, build a new product. Well, you cannot do that with your mortgage. Technical debt should not be completely eliminated. So you may identify a lot of technical debt, but maybe it should just stay where it is. It's not defect, the system works. Technical debt cannot be handled in isolation from other things that you have to do to your system. And in some cases, technical debt can be a very wise investment. So it's not a new concept. It was not invented in 92. It just gave a metaphor to something that we had known long before. There's been a lot of investigation on software evolution, especially of very large systems, and the concept of design erosion long before 1992. Actually, the Software Maintenance and Evolution Conference started in 1984. Technical debt is not defect. The software does work in the presence of technical debt. If you start calling defects technical debt or vice versa, you're confusing the issues. However, technical debt increases the likelihood of introducing defects. In presence of massive amount of technical debt, other developers may not understand the original intent and may introduce actual defects. There's a few cases where the boundary between a defect and technical debt is a little bit vague, but it's very rare. So if you want to contrast a defect and technical debt, the defect is visible. It's really affecting the users of the system. The technical debt is invisible. Defect is external quality. Technical debt is internal quality. Defect is purely a function of the past, whereas technical debt is both a function of the past, what you've done to your system, and the future, where you want to go now. Defect is rarely a good investment, whereas technical debt can be an investment, a way to explore, to mitigate some risk, to test a market, for example. Defect may have multiple causes. Technical debt mostly driven by schedule pressure. And technical debt, well, it's mostly in large and long-lived systems. If you have code that's only 3 months old, it probably doesn't have a lot of technical debt. So static analyzers, and there's many around, will detect much of McConnell type 1 technical debt. The most significant technical debt items, however, structural architectural debt cannot be detected by tools, or only a few, like cyclical dependencies, for example. But some team members may know about them. They know which are the architectural decisions that they've made that are greatly affecting the project. So measuring technical debt has been an objective for many researchers and consultants over the last few years, but I think it's a little bit vain. What is the cost of a technical debt item? Well, naively, it's the effort, the cost of the effort to bring the system to a state where the technical debt is not there anymore. But is that really what you want? Well, we have to distinguish potential debt and actual debt. Potential debt, it's only looking at you've done so far, what you have in your code today. And actual debt, it's when you know the way forward. Because if there is a large amount of technical debt in a subsystem, a part of your code that you're never going to touch in the future, whatever extension you're going to make, well, leave it. You don't need to repay that technical debt. So technical debt is not a mere function of the past, what you've done so far to reach the current state, but it's also a function of what you want to do in the future. So it cannot be assessed solely based on the current state. So the metaphor breaks a little bit, and people have been looking for better metaphor. One that's amusing is an unhedged call option, but a metaphor is only useful when you can transpose the source domain to the target domain. So if you don't know what an unhedged call option, it's not going to help you understand technical debt. We can try another metaphor, technical debt as an investment. You may find that taking some shortcut in order to get early a prototype with which you're going to validate what the market wants or what may be a good investment, because you may decide to abandon a certain path without having developed a lot of effort. Something that I run into very often is, we're agile, we do Scrum and XP, and therefore we're immune to technical debt. Well, I've seen cases, some dramatic ones, where you run actually faster into technical debt when you're agile. When you keep saying defer decision to the last responsible moment, maybe there is some architectural decision that you've postponed too long. And then you've made some architectural decision that will be very hard to change later on. You ain't gonna need it, yeah, but maybe you accumulate a little bit too many Yagni features, and so there's always the excuse that we'll refactor this later. Yeah, but sometime later, when later is a couple of years later, it's extremely hard to refactor, especially technical debt at the architectural level. And there is that push to deliver value early, right from the first 2 iterations of your development project. So there's always this tension that we see between big upfront design and emergence of the right architecture. And sometimes you're still agile because you aren't slowed down by tech debt yet. So what can you do as a software development organization about technical debt? Well, there's some tactical action, short-term, limited scope, and with some actual means. You can use tools and add some process steps in your software development process. You can have an immediate plan. And there's more long-term strategic stuff, which may have a wider scope, but may be more expensive and difficult to introduce in your organization. So the first step is awareness. You can organize meetings with your team to make them aware of technical debt, give them examples of technical debt, present them some of the slides that I'm presenting to you. You can create a category technical debt in your issue tracking system so you can actually start identifying it. You can standardize the self-admitted debt by having comments that have the form fix me or fix me later. So that they'll be easier to spot in the code a little bit later. Then there's identification, being more systematic in identifying code smells, and maybe using a tool. Don't be desperate too much. When you start using a tool to detect code smell, you may have thousands of notifications. So you need to tune the system to narrow down to what is actual technical debt so that you can manage it. You need to have some triage step. And at each now development cycle, start reducing some of the technical debt by bringing it explicitly in your iteration backlog or your sprint backlog. Then you may want to roll up your sleeve and look at impact and cost of technical debt. And this is difficult because not only software estimation of effort is difficult, but here we're looking at something that we may not even have to fix. So starting identifying, maybe just, a few categories, extra large, large, medium, small, extra small, may be sufficient rather than putting some numerical value. At some point in time, especially if you have a large system, you'll need to look at architectural debt. And you need to refine, your identification of debt into code level debt versus structural or architectural debt. You may find tools to help you identify some architectural or structural debt, but actually, the best way is to get it out of the brain of your software architect or technical lead, the people who've done the design decision 2 or 3 years ago at the start of the project. They know what is hurting today. And then you can put some process improvement. You can try to limit the amount of technical debt, especially code level technical debt that you introduce in the system. One strategy also is to have good regression testing, because you'll be more comfortable fixing your technical debt if you have confidence that you're not going to degrade your system. So technical debt, it's a little bit of a messy concept. It's something that is difficult to isolate or tokenize. It has a lot of dependencies on other things that you do in software development. It's not very easy to assess. And the cost and value of technical debt is very dependent on the future evolution of your system. And it has this sort of polymorphic aspect to it. It's good and bad, it's costly and beneficial, it's harmful and innocuous, all at the same time. So technical debt, all systems, especially when they grow large and long-lived, when they're successful, accumulate technical debt, and this technical debt is different than defect. How much you suffer at some point in time depends on where you want to go, not just where you've been so far. And code level technical debt nowadays is easy to identify. And to a certain extent to remediate architectural debt. It's a little bit harder to put your hands on it, and very often it's almost impossible to remediate. And then being agile should not make you too blind to technical debt. You can still accumulate a lot. If you want to read more technical debt, you can look at my website, and also with my colleagues from the SEI, Robert Nord and Ipek Oskaya, I wrote a little book about technical debt with more details, and you can find this presentation and the slides of this talk on my website. Thank you.